So in today's class, let's start with something called as exception handling in Java. Let's try to see why we need to do exception handling and what is the reason behind exception handling being written in any program. Okay, why? Because nowadays, like any program that you write, 100% of the programs, anything that you write, we will be writing or we will be using this piece of code, like exception handling code, in each and every project and each and every method of the class that we write. So we'll try to see what is the specific reason for doing this, or what exactly is this exception handling and how it helps us to run our programs. Okay, create a package for exception handling. Exception handling and the name that is some demo class I've created. In the main method, the first thing that we will do is I'll write a simple program dividing two numbers, and I will try to show some outputs and execute them. Okay. So I'll print this out, and then int c equal to, let me define int a equal to 5, b equal to, okay. Now I say c equal to a by b I wrote this out. The value of c is, then I say this out. Okay. So this is what is being. In this specific method, I wrote a sysout statement like at line number 7 and line number 11, and they are just some random sysouts. And at line number 10, I am just trying to print out the output for the line 9, or I'm trying to see what is the output when you divide two numbers. Okay, so when I execute this, things look pretty easy or simple, and the output is 0, and everything prints. Okay, it's printed. Now let us assume that there is a scenario where instead of passing the b as a regular whole number or any normal number, if you pass 0, okay, things are good if you pass a non-zero value for b, but if you pass 0 as the input for b, let me execute the same old program. Once again, if I run it, or if I run it again every time, there is a specific problem that you notice here. Line number 7 has been executed. Line number 8, 9, okay, let me debug. 7 is good. Line number 8 is good. Now when I execute line number 9, c equal to a by b, 5 by 0, which is kind of infinity. So which means that is a wrong scenario. Cannot store infinity into int. Okay. Now if I complete the execution, if I go to the next line, see what happens. It went somewhere, but ultimately it printed some error message for me, and at line number 11 it is trying to skip this line number 11. Okay, so what exactly is happening in this scenario? Why a line number 11 is not being printed, or line number 10 is not being printed? Why? Because at line number 9 there is an exception in the program. So an exception is something which is caused in a program either by wrong coding standards that we follow, or some improper coding that we do, or because of some improper data that we did not handle in this scenario, right? So in this scenario, it's because of improper data that we try to give for B. Means I don't say like it's an improper data, it's a valid data, but still at line number 9, if I can write my code in such a way that it can handle these kind of scenarios, then the execution of the program will be fine. If not, it will cause some exceptions. Okay, so so in a regular scenario, if you try to run this program by giving a different input 10, 11, 12 or anything uh, to anything, it gives a valid output and it executes the entire program. But not if I give 0. So that is a scenario where an exception occurs in a program which stops abruptly the execution of the program. Okay. Now the scenario, is it clear? Like what is happening when I say b equal to 0 to everyone? Okay. Now that's good. Now the next part, understanding the next level. I'm debugging the program. I'm at line number 7. Okay. Execute, execute. Then when I try to execute the next one, it did not, but it is throwing an error. Why? Why? Because of line number 9. So what happens exactly when an exception is occurred? Okay. So what is an exception here? Exception scenario. In general, when you're writing some code, okay, when you're writing some code because of, as I already mentioned, because of wrong coding standards or wrong code or improper data, due to lack of validating the data while before processing, all these things lead to some scenarios where they will stop your program abruptly because of some exceptions. Exceptions are something which are caused by human intervention. So in general, in Java, there are two types of errors or exceptions that can happen. So the first thing that we need to know is like we need to understand the hierarchy of this exception handling in Java. Okay, see here. Like object class is the parent of all classes. The same way in exception hierarchy, object is always the parent. So we are not talking about the object. We are talking one level below that. So throwable is the parent of all the classes, and below throwable there is something called as an error and an exception. So an error happens because like a simple example that I can say is like when there is a power failure, when you're trying to execute some program and if there is a power failure, then the scenario which happens is considered as an error. The same way, if suppose if you're trying to send some data onto the database and want to store some data or retrieve some data, if suppose if there is a cut in the network cable, then it is again an error scenario. Or if suppose if you're trying to create a program where it creates a lot of objects in the memory, and by mistake if you write an infinite while loop or a for loop which creates a lot of objects in the memory, then it consumes all the internal memory and it throws a scenario where out of memory exceptions and all these things, they are again errors. So errors are something which you cannot handle. Okay, if there is a power failure in a system, you cannot do anything. If there is a cut in the network cable or something, you cannot do anything. So those kind of scenarios which you cannot handle are considered as errors, but something which you can handle are called as exceptions. Okay, exceptions can be handled. How you can handle an exception, or what is the advantage of handling an exception? If I handle an exception, okay. Oh, okay. If I handle an exception, the advantage of exception is even though if something goes wrong in the program, I can still make sure that the program runs without any intervention. Okay. In this example, the program breaks out at line number 9 and is not executing line number 10 and 11. But when I do exception handling, I can make sure that even if something goes wrong in the program, the next steps can work fine or the program can run completely. So in this current scenario, what is happening at line number 9? At line number 9, when an exception is generated, okay, when an exception is generated, it does not understand what exactly to do with that exception. So it gives back the exception to the caller of the main method. So can anyone tell me who is calling the main method? Anyone? Okay, it's not the demo, it's the JVM who is calling the main method. So when an exception occurs at line number 9, the exception is given back to the caller of this method. The caller of this method is JVM. Again, JVM, when it receives the exception, it cannot understand what to do with that exception. So the JVM stops the execution of the program abruptly. Okay, so is that clear to everyone, like why the program is stopping at line number 9? Everyone, is that clear? Because exception handling is one scenario which you write in every class in Java. Why? Because it's not like you can skip in something or you can write in some, every each and every class, almost every method you write these exception handling scenarios. That's the reason why you need to understand this, you know, in and out of these exception handlings. Okay, so now we understood the basic concept, like line number 9 is causing an error. Okay, let me write one more scenario. This out all zeros, or let me explain how to handle these scenarios first and come back to the next example. Created a class called dummy. Let me copy paste the same old method. Control Shift F, formatting the code. Okay, now the next thing that I do here is I told that we can do an exception handling. Handling an exception which is generated in our application. So now what I do is when I execute my program in the previous scenario, it is causing something like exception in thread main, java.lang.arithmetic exception, divide by 0, and in the program demo in the main method at line number 9. So see the error message or an exception message that is being printed in the console. It is very much informative. So most of the exceptions that come in the program print a lot of meaningful messages. Okay, so how it prints these messages or what is happening in this scenario, we'll see now. Okay, the first thing, what I will do is I will write this piece of logic from line number 9 to line number 11 inside some block of code where even if an exception comes, your program can run fine. Okay, so let me write it and explain it later. So I will write something called as a try block. So in a try block, I will write some logic. and finally write something called as a catch block. And to the catch block, I am passing an object of type exception. See here, this is a kind of a block which is expecting an object of type exception. Okay, now see here, inside the try block, okay, I write my logic, and in the catch block, for time being, let me write something like this out. The exception is caught here. Okay, that is what I have written. And now let me execute the program. Let me debug it. Debug line number 6, then went to line number 9, line number 10. So line number 10 will definitely throw an exception. When it throws an exception, what happens in the previous scenario? In the previous scenario, no one can handle the exception. In demo.java I'm talking about. So in the previous scenario, the exception is given back to the caller, who is nothing but the JVM, and JVM also cannot understand what to do, so it stops the program abruptly. But in this scenario, when line number 10 throws an exception, see where exactly it goes. See, there is an exception and it went to the catch block at line number 12. Why? Because catch is something which can catch an exception which is generated in a program. Okay, so it went inside the catch block, the exception is caught here, is being executed, and then line number 16 is also being printed for you. Okay, program is completed. Now did you notice in this scenario the program has been executed from end to end, but in the previous scenario we are unable to see the output for line number 15 at least. Okay, so is that clear to everyone, like how we handled an exception in a program? Okay, that's good. Now let's understand a different scenario. Here what I will do is I will write an array, I will create an array in arr equal to, okay, sorry, what's the question? Mm,
So we got the exception at line number 12, right? That is C.
mm-hmm.
So if after line number 16, if we want to use C again, so we should create any other try block.
After line number 16 you
Like,
want to use C, is it
yeah,
like,
if there is a case that we use C after line number 16.
is this what you want to say?
No. So using the variable C, if we use something after line number 16, like D equal to C, something like that. So, but at line number 11, the system is, the exception is created, right?
Mm-hmm.
So at line number 17, I cannot use that C again. So will that show error, or what would be the case?
Okay, you mean to say int D equal to C like this?
Yes.
Okay, we will see this example later. This is considered as kind of a scope of a variable C. See, in this current scenario, you cannot use variable C, right? But here,
Yes.
why? Because the variable C has a scope only within this block. Okay, it cannot see outside that block. So, understand. Since we did not look into the scope, I might not be able to explain that right away. But for your understanding, if I declare C here, int C equal to 0, initial I told, then C equal to A by B, I told, then I can happily use C here. Why? Because the scope of C is declared inside the main method. So it can be used anywhere in the main method. But in the previous scenario, see here, I am declaring outside a try in the current scenario. But in the previous scenario, it is declared inside the try block. Since it is declared inside the try block, the scope will be only inside this one, so it cannot see outside. That's for now. That is a explanation that I can give for now. Okay. That's good. Now see here. The next example that I'm trying to say is at line number 9. I have created an array of 5. Then I said array of 7 equal to 2. That is what I have assigned. So is there anything, is there a mistake at line number 10 or no? So what happens at line number 10? Size problem. Very good. So the scenario here is, in the current example, a simple scenario. The first one is exception is happening at line number 10 because you are trying to access an index. So you have created an index only till 5, but you are trying to access an index which is out of the range. Okay, so I say here, when I execute this program, again an exception is caught. Okay, that is what is happening. Now see here, if I try to debug the program and show you, it shows something like line number 9 is executed, line number 10 is executed. Now understand the scenario very carefully, because line number 10 causes an exception. None of the lines below line number 10 will be executed. Okay, none of the lines below line number 10 in the try block only will not be executed. So it will not execute line number 12, line number 13, line number 14. It will directly jump to line number 15. See here, because of exception at line number 10. Okay, which means all these lines will never be executed. So, but still, since an exception is coming, it executes this system dot out dot println, and the exception is caught here. That is what is being printed in this scenario. Okay. Now, let us try to see what exactly are the kind of exceptions that are happening. E is a reference variable of type exception. Okay. Now, E dot print stack trace. Okay. Print stack trace is a method which is already given, or which is already defined in this exception class, so that it can print some error messages for you, like what is happening. Now if I debug it, exception is caught here. So when line number 17 is executed, see here, see what is being printed. See, it shows java.lang.array index out of bounds exception at line number 7. Sorry, the index is 7 that you are trying to access in the class dummy in the main method at line number 10. This is what is being shown. So at line number 10, because you are trying to access an index location 7 which in an array ARR, that is an out of boundary, that is the reason why it is causing this exception. So the exception is of type array index out of bounds exception. Okay, so complete the execution. Okay, now what exactly is this array index out of bounds exception? They are nothing but classes which are already pre-defined in Java. So what exactly Java told is, hey, in general, when people start coding, they might do some common set of mistakes. The common set of mistakes that they can do are something like they can divide by 0, they can use an array index out of boundary, or they can these there are different sets of exceptions that Java has already identified and has given it for you, which means if I go to this array index out of bounds, or else let me define it here and say array index out of bounds exception. So this is a pre-defined class in Java. So if I go inside this class array index out of bounds, you might notice that array index out of bounds exception is extending from index out of bounds, and index out of bounds, if you go, it extends from runtime exception. So I want you to see something here in this example. So exception, below that exception you have runtime exception, and below that you got some kind of subclasses again. So runtime exception, if I go on to runtime exception is extending from exception, and if I go inside exception, exception is extending from throwable, and if I go inside throwable, that is the parent class in Java. So see here, throwable is the parent or the topmost in the hierarchy. This is one of the interview questions. People will ask you, can you tell me the hierarchy of exception handling? Hierarchy means what is the topmost class and what are the classes, subclasses followed by them. So throwable is the topmost class in the exception hierarchy, and below throwable you do have a class called exception and error. So we are considering only exception in this scenario. So below throwable, so if I close this throwable, you have something called as an exception, which is a child class of throwable, and then exception again has some subclasses. Under exception, if you see here, there is something called as a special class called runtime exception. Okay. Now I come to a class called runtime exception, which is extending an exception class, and this runtime exception class again has some subclasses, and one of the subclass that we saw is arithmetic exception or null pointer exception or array index out of bounds exception. Like that, there are many exceptions. Okay. So index out of bounds, let's not worry about index out of bounds, but if you consider index out of bounds is extending from runtime exception. So in Java, in exception handling, there are examples of subclasses which are broadly classified into runtime exception classes, and these classes are considered as maybe they are not runtime exceptions for now. Okay, we will see an example of what is runtime exception and what is a compile time exception classes and all, but for now just concentrate on this runtime exception class. So the first question, is the hierarchy clear to everyone? Okay, yeah. So an array index out of bounds exception is a class which is defined by Java, and it says that, hey, if suppose in a program, if the user tries to access an array out of its boundary range, then Java internally identifies that as a specific type of exception and throws back that exception message for you. Okay. Now let us assume that ARR of 2 or 3 or something I say. Now, will there be an exception at line number 10 or not? Very good. The answer is no. Now, the next question. Will there be an exception in the program or not? At line number 13. Very good. Now, the next question. Can the understand this question very carefully and answer my answer to that. Can an exception which is being thrown at line number 13, can it be caught by the catch block or not? Can a catch block catch that or not? Someone said no, no. What about others? Yes. Okay. Yes. Any reason why, Padma, it is yes?
Yes, because it is not accepting 0, so it prints as exception is caught here.
Okay, so an
Arithmetic exception, yes.
very good. So at line number 13, you get an arithmetic exception. So you throw an arithmetic exception from line number 13, right? Okay, now answer my question, Padma. Is there a block in the current program which can catch arithmetic exception? Yes or no? Did you get my
Block in the
question?
sense, I'm sorry, I didn't get you. No, I'm sorry, I didn't get you.
Okay. So at line number 13, what is the exception that you are that is happening?
Arithmetic exception.
Arithmetic exception. So first question: in a program, when an exception is raised, who catches it? Which block will catch it?
Throwable.
No, no, no. Which block can catch that exception? So the answer is a catch block can catch that exception, right? See,
Okay, yes.
what is the use of a catch block? Catch block can catch any exceptions that are being generated in the try block. Is that clear? First of all, to everyone.
Okay. Yeah.
Okay.
Yes.
So Padma, at line number 13, what is the exception that is being generated? Arithmetic exception, right?
Yes, arithmetic. Yes.
Now, my next question.
Arithmetic.
In your program, is there a catch block which can handle arithmetic exception?
Yes.
Okay, at what line?
15.
Okay, line number 15, catch block can handle what type of exception? What did you write in the code?
Array index out of bounds exception.
Array index out of bounds. When it is accepting array index out of bounds exception only, can it accept arithmetic exception also? Yes or no?
I think no.
Yeah, that's good, very good. The answer is no. Okay. So why? Because
Okay.
in general, let us assume that, okay, let us assume that uh, there is an exam, there is maybe a simple example, maybe, it might not suit, but a straightforward scenario that I can say here is my catch block says that, hey, if you give me, or if there is an exception of type array index out of bounds, then only I can understand, or then only I can catch it. That is what the catch block is telling. Any other kind of exceptions, your catch block cannot understand. So see here, I have a debug point at line number 6. It stops there. So line number 10 is valid scenario. Good. Now there is an exception. There will be an exception at line number 13. So everyone will think that, everyone will understand that because of line number 13 exception, because of line number 13 an exception will be generated and it will be thrown. When it is generated, can a catch block catch it in this scenario? The answer is no. See, catch block did not catch it. It has it is sent to the JVM. JVM did not cannot know how to handle, so the program execution has stopped and line number 20 is not printed for you. Okay? Why? Because we did not handle arithmetic exception. Okay? Yeah, I'll come to that, Azim. I will come to your question. Okay? So now I will say on second thing. Yeah, sorry. So in this scenario, what I will do here is array index out of bounds exception is only I'm catching. Okay. Now let me add one more block. I say catch arithmetic exception. Again, a variable e or ex, same thing in any variable name that you can give, and this is out e dot print stack trace or ex dot print stack trace. Okay. Now, team, everyone, can you tell me, like, in to which catch block it will go? Line number 15 or line number 18? Line number 18, 18. What about others? Awesome. Very good. Okay. Now, there is a slight change that I make here. Tell me where exactly it will goes. Where exactly it goes. Line number 15 is what someone says. What about others? Both, someone says. Okay, 15, 15, 15. Okay, that's good. So only 15, that's good. So the explanation that I'm going to give is for someone who told the answer as both. Okay, so understand here. The basic scenario is anytime when an exception comes in a program, okay, when an exception comes in a program, and if the logic is written in between the try block, okay, in a try block, then if an exception occurs at line number 10, none of the lines below that will be executed. Okay, so line number 12 to 14 will never get executed. Okay, so it's only like after line number 10 it checks it is array index, so it goes into line number 15, okay, and executes this program, and it comes out of it and executes line number 23. Okay, now I'm not sure if everyone has tried this one or not. The scenario that I'm going to explain right now, string s equal to null, okay, and I say s dot, so s is a string to which I have declared null. Now, if I say dot equals or dot length or anything, if I use any object which is null, null dot will give me a null pointer exception. Okay, null dot will always give me null pointer exception in Java. So at line number 10, I am telling explicitly that it will throw a null pointer exception. Yeah, Adit, just a second. Let me complete this and I'll take your question. Okay, s dot length will say a null pointer exception. Now answer my question. To which catch block the exception will be thrown and where it will be handled? Or who will handle this? At present, no one. I think none. Okay. Arithmetic, I'm guessing. Okay, see, I'm explicitly telling that it is not arithmetic. It is a null pointer exception. Null pointer exception is again a class in Java. Okay, so my next question: can either of the catch blocks handle the null pointer exception? Yes or no? Very good. Answer is no. Now, see what I'm trying to write here. At line number 24, I say catch exception e this out e dot print stack trace. Okay. Now see here, team. Null pointer exception. Okay. See here. I will explain the scenario, but my next question, the same old question. When an exception occurs at line number 10, can anyone handle this exception? 24 is what someone says. Yes, someone says. Okay, very good. The answer is 24. That's correct. An exception block. Why? Because if you see the hierarchy, all the subclasses, arithmetic exception, null pointer exception, array index out of bounds, any kind of exception in the current scenario that I am discussing, okay, which extend from runtime exception. See, I'm only talking about the right hand side. I'm not considering about the left hand side, okay? All the right hand side exception classes means in general sometimes you might ask, hey, how do I know that the right hand side is a runtime and the left hand side is not? A simplest way to do is whenever you create a class like array index or arithmetic, go into that class which is defined by Java arithmetic exception. It extends from runtime exception. So any exception, if it is extending from runtime exception, then it falls into runtime exception category. Any exception which does not extend from runtime exception will fall into this left hand side category. Okay, we'll see the left hand side later. Let's start understanding this one. So now all we are dealing with is runtime exceptions. Now, when an exception happens at line number 10, means any of these exceptions, what I am trying to do is, first, I am trying to see, is it of arithmetic or is it of, sorry, array index or arithmetic? Since it does not belong to any of them, the first two catch blocks will never handle it. But at line number 24, I am handling at a parent level. Okay. So which means this parent can understand any of the exceptions. Even it can understand all these kind of exceptions, or even it can understand all these kinds of exceptions, which means anything and everything which is below an exception block can be handled by the exception. So what we do is, like whenever an exception is happening, or whenever we say like we know specific kind of exceptions, we write it in the catch block with those specific exceptions, and all other exceptions can be handled in an exception block. So now if I execute this program, line number 10 causes an exception which goes into line number 25. It prints 555 and it says, hey, it is a null pointer exception which is being caused by that exception at line number 10 in your current program. So this is that. Okay, so I hope it's clear. Adit, can you go ahead with your question?
Was that me?
Yeah, you had a question, right?
Sorry. Yeah. I didn't mean to go out of track here, but no, I just noticed when you did s.length, I've been noticing that whenever you go through that, you see the percentage on the side.
Mm-hmm.
Is that kind of new thing?
Yeah, I guess like it's a new thing. Even I am just looking it for the first time. Like I think it is being shown in Java 8. I think like there are, and the first time I'm just noticing like the star symbol, which might be like the number of times the method is being used, or to be frank, like
Or like the probability of us using that, you know?
yeah, might be that's what I say. I think,
Okay. Okay.
but
Yeah,
I'm not sure.
I had noticed that percentage before, so I was just kind of curious. That was
Okay,
it.
but till now I was using Java 7. Till Java 7, like I never noticed these percentages, but this is the first time I'm using Java 8 too. So I think like
Also, so you don't think it's like the Eclipse thing?
uh maybe Eclipse also maybe one of the features in Eclipse which try to show.
Because now we're using the new one, right? We're not using Luna anymore.
Okay, yeah, maybe I think the Eclipse feature also. Yeah, I'll just try to Google
All
it
right.
and see. Okay.
Gotcha.
Uh, yeah, Padma, that's correct. Since s
Yeah.
equal to null, it causes a null pointer exception. Okay. So no, any object by default if it is null. See, we are in dummy class, right? So let me do one thing, one more scenario. Yes, I go ahead with the question.
Yes, Raghu. So, is there any use of writing exceptionally like arithmetic exception or array index out of bound exception? Like, is there any use like the time of execution time will be reduced if you explicitly write arithmetic or something like that?
Yeah, that's a very good question, and that's what my next topic is also. But to answer that question, the answer is yes. In general, what we do is like in a program, if you're writing or if you're writing a huge amount of code, you need to differentiate. Means, let me talk in a real-time scenario. In a real-time scenario, if suppose if there is 100, there are 100 lines written in a try block, and if an exception happens because of an array index out of bounds, you want to take a different route and you want to show a different message to the user. If an arithmetic exception comes, you want to take a different route and you want to show different message to the user. So in general, what happens is we try to catch exceptions at the lowest level possible instead of at a higher level. So we try to catch them at the lowest level, do whatever stuff we want to do exactly for those exception scenarios. Which means when an array index out of bounds comes, I want to show only 4444 to the user. If arithmetic exception comes, I want to show 333 like that. So you can handle, I'm just an example this out, but this is not what in a real-time scenario. But if there are any specific actions to be performed, you need to know what kind of exception it is. So you should do that. And in general, we try to avoid or we try to skip this scenario, catching an exception at a higher level. Why? Because if I do this, it will not be clear to me like what exactly is the exception which is being caused by and all. I cannot handle all these scenarios in a proper manner. Okay, yeah, precision will be more. So catching exceptions at the lowest level is what is in general is prescribed actually. Okay, yeah. Now for your question, Padma, like see here, not only string s equal to null, even if I say demo, I am trying to create an object for type demo. So demo d equal to null, I say now d dot, I can say anything, d dot toString, d dot notify, d dot wait or anything. ToString I said. Now again, because of line number 10, it will cause an exception. Okay. So now if I execute the program, it shows, see, line number 10 in the Java program in the main method in dummy, it is causing an exception, which is nothing but d dot toString. So any any object which is null, on that if you do dot and call any method, it will cause an exception. Okay. Awesome. Now moving on to the next topic. The way I wrote the exceptions are array index out of bounds at line number 21 and at 24 arithmetic exception and at 27 exception. Now my question is, can I cut this logic or it's not cutting? Can I remove this logic here and can I place it at line number 21? Can I place it like this? Yes. Very good. Okay. The answer is no. Why the answer is no is, see here. In a general scenario, if any kind of exception comes, the parent can always handle, right? The parent class, which is an exception, can handle any kind of scenario, right? Exception can handle any kind of, or it can take any kind of exception. So when an exception happens at 10, this can handle. At 13, this can handle. At 16, this can handle. Or at line number 19 also, the block 21 can handle any kind of exception which is coming in your program. My next question, if line number 21 is handling all the exceptions, will 24 and 27 be called at any point of time in this example? Very good. They can never ever be called. So handling the parent first is a wrong scenario. Why? Because it can eat up all the exceptions for you. Okay. Okay, so this is how it should be. The children first and then the parent. Okay, the level in which or the type in which you need to write these scenarios are like always the child class exceptions, then followed by the parent class exception. Okay. Now, all these exceptions that we saw till now are something called as runtime exceptions. Now, in this example, I will try to show you how you can handle compile time exceptions. Okay. So now we are talking about the left hand side scenario. Okay. So anyone, any guess like what are compile time exceptions? Okay, okay, maybe I'll take it from here. IO SQL. Okay, very good. So when you say IO and SQL are kind of compile time exceptions, any difference that you can say between a compile time and runtime? How can you notice or how can you differentiate them? Okay. So the one thing that you can say is you can always notice that if expert compiling, what is that? Compile time would have read X while compiling. Okay, sorry, I did not get that one. But the answer to that is like the first thing that you always know, like what you can do is like you can check if it is extending from a runtime exception class or not. If it is not extending from a runtime exception class, then you can always say that the runtime exception class means any class which extends all those are considered as a runtime. All other things are compile time exceptions. Now let me take an example here, say test class. So in this test class, let me write a main method, and in this main method, I say file input stream. File input stream is one of the files which you use for the dealing with file operations, input output operations. Control Shift O to import that class, java.io.file input stream. Then the next thing that I do here is fis equal to new file input stream of c colon slash abc dot txt. Okay, we are not trying to understand what is except file handling here, but we are trying to understand what are compile time exceptions. Means in general there are two technical terms that are being used. One is like checked exceptions, checked exceptions and unchecked exceptions. These are the two technical terms, and unchecked exceptions are nothing but whatever we saw till now. Runtime classes which extend runtime exception. Okay, so runtime exception is all one class. So let me say and checked exceptions are classes which extend exception class directly. Okay, so we are looking into checked exceptions right now. So here this is what I said, and then let me do this out. This out. Okay, so before I execute this program, let me go back to my old program like dummy.java, and in this scenario line number 10, okay, line number 10 will cause an exception for sure. Why? Because D is null. Okay, so it is for sure it is causing a problem. Now question to everyone, even though line number 10 will cause an exception, like we know that it will cause an exception. Is the compiler complaining, saying that, hey, there is an exception which will come at line number 10? Is it complaining, the compiler, or not? Okay, very good. The compiler is not complaining. But if you go back to test.java, at line number 12, there is something which is being shown as an error, which the compiler starts complaining. So if you see here, if you hover your mouse here, it shows unhandled exception type file not found exception. Okay, did you notice here it shows file not found, which means in scenarios like IO operations, IO stands for input output operations, or any SQL operations or anything that you do, the Java compiler says that, hey, today you are trying to write that, go and read from a file called C in a C drive, abc.txt. That is the file that you want to read. Well and good. Let us assume that it works today. By mistake, tomorrow if you go back and delete that file abc.txt, then your program, when it tries to run by reading that file, will stop abruptly by throwing an exception saying that it cannot find the file. Okay, a simple scenario. Today you might create a file called abc.txt. After some time, like a week or two or month or a year or sometime later, by mistake, if you go back and think that, okay, this file I'm no longer using it anywhere, so if you delete that file, come back and execute this program again, this program might not find that file anymore. Why? Because that is not present at that location. So at that point of time, it might cause an exception. The same way, if suppose if this program is running fine in my machine, if I share all my projects with you, and if you start running your program, the file or the program which is running fine in my machine might not run in your machine, because in your machine there might not be a C drive, or there might not be a file called abc.txt under the C drive, right? So it means that the Java compiler says that, hey, these kind of exceptions you must handle well before you write your program, or sorry, you run your program. So these kind of exceptions which the compiler forces you to handle. See here at line number 12, the compiler is forcing you to handle the exception, but in none of the cases like line number 10 or 13 or 16 or 19, in none of the cases in this current scenario the compiler is forcing you, right? But in this scenario the compiler is forcing you to handle. So what I say here is, the if the compiler forces you to handle something, then they are called as checked exceptions, which means you need to check them before you run the program. And any exceptions which the compiler will not complain you, I'm talking about the compiler, I'm not talking about the JVM. When the compiler is not complaining about them, they are called as unchecked exceptions. Why? Because in unchecked exceptions, the compiler only looks for syntax, whether it is a right syntax or not. It will not worry about an exception or not. But in these scenarios, it worries about that, hey, this might cause an exception in future, so you better handle it. So there are two ways of handling these exceptions. See, if you hover your mouse, the first thing it shows is add throws declaration. This we will see later. But the other one is surround with try catch block. So this is what I will do. I will select this option, surround with try catch block. So now if you notice here, this piece of logic which might cause an exception is placed inside the try block, and it is having a catch block which is saying that file not found. Okay, now this out. So now if I go ahead and execute this, the abc.txt is not present in my program, so it will definitely cause an exception. It will print 1133 and also prints 22. See, 113322 is printed, and also it prints e.print stack trace. Because of this line number 18, it is printing all the exception, file not found. The system cannot find the file specified. Okay, so these kind of exceptions in general if you go to file not found is not extending from runtime exception. If you go one level above in the hierarchy, this is extending from IO, input output, and IO is directly extending from exception class. See here, IO exception is directly extending from exception. There is no runtime exception class in between here. So all the left hand side exceptions in purple are called as checked exceptions. All the right hand side exceptions which are in yellow are called as runtime or unchecked exceptions in Java. So unchecked exceptions you need not handle at compile time. Yes, there will be an exception at runtime, but these checked exceptions must be handled at compile time itself. Okay, is this concept clear to everyone? Any doubts or any questions or anything? Plus E instead of line number 18. So what do you mean by that? Like when I say sys out E, is this what you mean to say? Sys out E? Okay. E is an object of type file not found. Okay, E is an object of type file not found. So it just shows you that java.io.file not found exception. This is the specific message that it is printing. Okay, because you are using a sysout. Okay, because you are using a sysout, it is printing that. But without using a sysout also, you can directly use e.print stack trace. So in general, what happens is whenever an exception happens in the real-time scenario, okay, real-time scenario, people will call that as, hey, what is the stack trace? Find out the stack trace so that we can understand or analyze the program. So e.print stack trace is what we use. But in a real-time scenario, we will not use e.print stack trace directly. There is some other mechanism that is called as a logging mechanism that we will see in our future classes. Okay, that is how you handle it. But for time being, to print all the exceptions or what is happening, that is what I am using e.print stack trace. If not, you can always use this out e, which will print a shorter version of what we saw here. Okay. Okay, that's good. So right now we understood like what is an exception, how to handle that exception, and what are the different types of exceptions like a checked exception and unchecked exceptions, and how to handle these two different types of exceptions. This is all is done. Okay. So now moving on to the next step. Finally demo. So I do have a main method. Let me copy this dummy, and whatever example that I'm going to explain right now, okay, whatever I'm trying to explain right now can is similar to both checked exceptions and runtime exceptions, which means like I am trying to explain a new block. Till now we saw two blocks, try block and a catch block. The next block that I am trying to explain is a finally block that you can use either for checked exceptions or for unchecked exceptions. So basically, when I take this example, people might think that can it be used only for unchecked exceptions? The answer is no. It can be used for anything. Okay. So maybe if you want me to mix and match both, what I can do is like I can write this line here, file input stream. Finally demo. So Control Shift F. Then I say see, one more thing. Line number 12 is not complaining in this scenario, even if I am not handling file not found exception. Any reason why? Anyone? Any guess? Very good, Sai. Because of line number 32. Even though I'm not handling the child like file not found exception, Okay, even though I'm not handling this IO exception, I'm handling at a parent level exception. Since this can handle, since the exception, like the parent can handle this file input stream, it is not complaining. Now the question to everyone: if I remove line number 32, will it cause an exception? Means will the compiler start will the compiler start complaining or not? As simple as that. The answer is yes. Why? Because this exception is not of type array index or it is not of type arithmetic. So it starts complaining. So what I do is, instead of handling exception E, all I will say is like file not found exception. File not found exception. Okay. See, file not found exception is what I am trying to use here. Now, the next thing that I am going to explain here is like finally block. Finally this out. Okay, just notice here I'm just writing one statement in the finally block. Okay, now let me run the program and you see something called as 7777. Okay, which means finally is executed. Now my question, is there an exception in this program or not? Okay, the answer is yes, there is an exception in this program. Okay, now I'm removing this file not found and I will say exception E. Now my question, is there an exception which can happen in this program or not? So the answer is no. Well and good. Now let me execute the program again. Now my next question, is the finally block executed or not? The answer is yes. So the concept here is, a finally block is something which will always execute even if there is an exception or even if the program execution goes fine without an exception. Okay, so finally means ultimately executed even if there is an exception or not. Okay, now the next scenario. Yeah, even if we write without finally, it executes. See here, let me do one thing. This out. So I'm 1 second. Let me execute this. So 7778888 is being printed. Now I remove finally, save it, run it. It has executed well. Okay. Now the next scenario, this will cause an exception definitely. Okay. So it has executed, which means my intention is to explain you that when there is a finally block, that block will get executed every time, even if there is an exception or even if the program execution is fine. In both the scenarios, it will execute. Okay, is that clear? First of all, like when a finally block gets executed,
So even in this case also, if we write sysout without final block, it executes, right? So after catch, everything will be executed.
is this what you're telling?
Yes.
Yeah, I mean, that is what I'm telling you right now.
So then what is the use of a final block even after even without final block, it is getting executed, right?
Yeah, means yeah, I'm about to explain that. But the first scenario is finally, irrespective of an exception comes or not, it gets executed. That is the first thing that you need to understand. If that is clear, then I can go ahead to the next step and tell you why we write a finally. Okay, so since it is clear to everyone that finally gets executed irrespective of an exception or not, then so in this scenario, let me put or let me explain one simple example. The first one. In the try block, let us assume that you are writing a code where you want to talk to the database and then you want to establish a connection with the database and then you want to close the connection with the database. So you have written something like here, open database connection, and in real-time scenarios closing the database connection is very important. It's very mandatory to close any open database connection. So the first thing that you do here is open connection, do all the database operations, and then finally you say close DB connection. Okay, close database connection. Now in this scenario, there might be an exception which can happen because of line number 14 or 17 or 20 or 23 or 26. In any scenario, there might be an exception, right? So now, what exactly the finally block does is, if suppose if an exception comes in real-time scenario, what we can do is in a finally block, I will say, hey, is the DB connection open? If so, close it. That is what I do. So if the first scenario, consider a happy path in which none of these lines, let us assume that none of these lines in the try block will cause an exception. If none of the lines are causing an exception, then you assume that hey, this is a happy path and you close the database connection at line number 28. Well and good. Then you come to finally block. You check, is the DB connection open? Since it is not open because you have already closed at line number 28, you will you will not close it again in the finally block. But if suppose, consider a different scenario. If suppose, if the program execution has failed at line number 14, or any of these scenarios, if it has failed, line number 28 will not be executed. If it is not executed, then what will happen? It is not a right way of dealing with the database connections. You must close it. So when an exception happens, it can go into any of the catch blocks, but it comes to the finally block also. Once it comes to the finally block, you will check, is the DB connection open? Yes, it is still open because line number 28 is not executed. So you go ahead and close the connection in the finally block and you go further. Is it clear now, like the scenarios in which you use a finally block? Okay, so that is the reason why I said that finally block will be executed irrespective of an exception. Okay, even if exception comes, it gets executed. Even if it does not come, it gets executed. That's the scenario. Clear, team? Okay, very good. Now the next scenario that I would like to show here is one more class. System. In this scenario, I will explain a situation where I say that in how many different ways you can write try catch finally blocks. Okay, so you can write a try block and you need to add any other block along with it. A try block cannot stand on its own. It needs either a catch or finally blocks. So try catch exception E. This is a scenario which everyone knows. Okay, that is one combination, and try, catch, and finally. This is one scenario. Or try, finally. This is one scenario. Did you notice in how many different ways I'm able to write try, catch, finally, try, finally? Means these are the different ways of writing a try block. Okay. Now another scenario. I can say try. Okay. So string s equal to null try. I say int arr equal to, see, whatever I'm trying to explain at this current situation is like trying to write one try block inside another try block. Five also will cause an exception. Catch exception E. So now answer my question, King. In this scenario, what will be the output? Line number 35 or 39 or both or none? "35" is what many people say. 39 is what some people say. Okay. Now, very good. Now understand the scenario. It is inside a try block. So now in this try block, if you notice, this try catch scenario is present inside a try block. Okay. Now, first question, is there an exception in the internal try block or not? Yes, very good. Now, next question, is there a catch block which can handle that exception or not? Okay, again the answer is yes. So it is at line number 34. So the next question, understand very carefully and answer this. In the highlighted part from 31 to 37, okay, 31 to 36, there is an exception and the exception is suppressed. Suppressed means it is not being sent to anyone else. It is being caught. It is also handled at line number 34. Okay. Now inside the try block, from line number 28 to 38, will the try block, will it see any exception or not? Yes or no? Very good. It will not see any exception. Why? Because the exception which is raised in the highlighted part is already handled by line number 34 catch block and is already suppressed for you. So if I execute this program, see here, it only prints 1111. Why? Because that is the catch block which is handling the exception for you. Clear with this scenario? Okay, awesome. Now the next scenario, I will try to remove this catch block. Okay, and I will try to write something called as a finally block. Why? Because a try can exist with a finally. This out. Now look carefully and answer me what will be the output. And also I need, yeah, the line numbers. Okay, 35 and 39 is what someone says. What about others? 35 is because, what is it? Both 35 because of finally block. Okay, Azim, can you just look into that once again and tell me what is the answer? 35. Very good. Now, see here, team. The same old question. Is there an exception because of this try block? The answer is yes. Now, my next question. Is there someone who is handling or suppressing the exception which is raised at line number 33 inside the try block, inside the main try block? So very good. The answer is no. Since the internal try block, for the internal try block, there is no one who can handle it. It is propagated to this outer try block, where the outer try block assumes that okay, there is an exception in this try block. So the next thing that it needs to do is give it to its catch block. So it comes to this catch block also. That is what I want to explain. Like if something is not handled internally, it propagates to this try block, and this try block gives it to this catch block. Okay. So if you see, so 555 is already, everyone knows that that will be executed because of it is finally, but still it shows 2222 because the internal try block did never handled that exception, and the outer try block gave it to the catch block. Clear, everyone? Especially those of you who told only 35. Okay, very good. Now one last scenario. What will be the output? 13, 5, 39 and 41. All this. Very good. So 555, 222, 666. And just understand that whenever I say finally means it will be executed every time. Okay. So even if there is an exception or not. So finally is like something which is by default executed every time. That's the only thing which you need to remember. Now, if this is clear, is it okay to have finally? Okay. So that's a good question. See here. See, it starts complaining, saying that you cannot write it multiple times. But the next scenario is here I wrote finally twice. But if you notice, this is for this try block and this finally is for this outer try block. That is the reason why writing two finallys is valid here. But in general, for a try block, you write only one finally block. But multiple catch blocks, as many number of catch statements you want, you can write. Okay? Yeah, got it. Now the next scenario and the most and slightly, I don't say confusing, but kind of. So throw and throws demo. So I will keep this concept very simple. Okay. Now see here team. My first question. From now onwards, will you start writing any piece of logic without a try catch block? Very good. The answer is no. Why? Because from now onwards, start using, like, means in our going ahead, the next examples for some of them, I might not write a try catch block, but you start using try catch blocks. Why? Because you never know where exactly you might make a mistake, right? Unless it gets executed and if you catch it and if you print it and you notice, not know. So always try to write any set of logic that you want to uh, you write in your program inside a try catch block. Oh, sorry. Main is already written. Are we should use every kind of exception before it? Okay. For now, what I can say is like, yeah, I got your question, Adi. So for now, what I want you to understand here is start using an exception block E. If not, okay, to be more precise, what you need to do is like, if you're writing some 10 lines of code, in the 10 lines of code, if you're trying to use something like an array, try to use array index outer bounds. If you're trying to use an object dot, try to use null pointer exception, like that. Based on the set of codes that you're trying to write, handle all the exceptions below. If suppose, okay, if suppose this is the same old logic that you have written. In this logic, you forgot to handle arithmetic exception. Okay, you forgot, sorry, array index out of bounds you forgot to handle, but when an exception comes at line number 16 because of array index out of bounds, you go ahead, add one more catch block for that specific scenario, telling that okay, if an array index out of bounds comes, what I should do. That is how you need to handle. So you need to handle only specific type of exceptions, not everything like catch exception. Writing catch exception is not preferable, but at least since you're starting, since you might not understand like what everything that you can handle, first handle catch exception E. If it prints in the console saying that hey, it is caused by array index out of bounds, add one more child class array index out of bounds, like that. Try to find all the different scenarios, handle only the subclasses. Okay, now once in a throw and throw. Okay, we have a class called some class and it has a method called divide method. Okay, now from your class, what you want to do is you want to use a functionality which is given by someone else, like dividing two numbers. So what you do, you create an object for the class, some class sc equal to, and you say sc dot divide and pass 3 and 5, and let us assume that this will return an output like double, return a by b. Okay, now, okay, then statement catch exception e, return 0, non-zero, maybe a negative number. Okay, let us assume that a simple scenario that I'm trying to do is like, if everything is valid, I return A by B. If not, I return a negative number. Okay. So now I will get the output in the form of double. Okay. Now see here, I run it. It gives me the output. Well and good. Okay. Output is 0.0.0 something it goes. If not, let me make a change here. Let me make it as 31, and if I print it, it is 6.0. Okay, well and good. Now the next scenario, divide is a method which is given by someone else for you. You are not writing this method. Okay, so now in this scenario, if suppose someone else who has given this method, if they write something like this, see, whatever I'm explaining here is about two keywords, two different keywords called throw and throws. Okay, throw and throws. Now first let me say here as throw. Okay, let me say here as throw. Here what I do is I use a keyword called throw. What exactly I want to throw, or let me add one more scenario to this. If b equal to 0, okay, if b equal to 0, then throw new arithmetic exception, and I'm saying the denominator cannot be 0. Okay, see here. Okay, so whatever exception that I have created, like arithmetic exception, don't assume that hey, I should write divide by 0 exception. Why I'm writing arithmetic? My intention is not to explain what is the type of exception that we want to throw, but here I want to explain the use of a keyword called throw. Okay, so first thing, let's forget about throw. What exactly is the highlighted part? The highlighted part is nothing but new arithmetic exception, which means I am creating an object of type arithmetic exception. Okay, so when I say new student, what does that mean? I am creating a new student object, right? So here I am creating a new arithmetic exception object, and I say throw, which means hey, throw this exception. Okay, throw this exception, which means send this exception back to someone else. So when this exception is thrown, the catch block catches this. Okay, the catch block catches this, and you can say here, you can again rethrow the exception back, like throw new, the same old story that you can write here if you want. So if I execute the program, see here. Mm, if I execute the program, it prints 999 and it shows the output as 6.0. Okay, well, and this scenario is good. Now let me make this as 0. Now here observe what exactly happens. Did you notice here, team? It never executed line number 10. why it did not execute line number 10. Why? Because let me debug the program, explain this stuff completely. And team, whatever I'm going to explain is most important concept. Okay, if you don't understand, stop me. Okay, once I'm done with this, you can ask questions. So let me debug this. So at line number 7, I'm creating an object and then I'm calling divide method in this class, some class. Okay, now I say F5 so that I can go into the divide method. Now I went to the divide method. Here is the value 0. Yes, the value is 0. Once the value is 0, the user, someone else who has written this code, they are saying that, hey, I will not go ahead and execute any other logic. Why? Because the user is sending the value b as 0, which is an exception scenario. So I will explicitly throw this arithmetic exception. So any exception which is thrown from the try block is caught in the catch block exception. Why? Because this can handle all the child class exceptions. So it comes here and it goes inside, prints 111 for you. The next scenario, you are again explicitly throwing exception like throw new arithmetic exception for you. Okay, so when I say throw new arithmetic exception, the question to everyone. Okay, so first understand here, I am throwing back an exception. Don't worry about what kind of exception I'm throwing back. Here only understand that I'm throwing something back. Now my question is, to whom am I throwing this exception? What is the answer? To catch? No, wrong. So I'm talking about line number 13. To whom am I throwing this exception? User. It's kind of right, but the answer that I want to say here is, I am throwing this exception from line number 13 to the caller of this method. Okay, to the caller of this method, whoever has called it, to them I am calling. Now one question, is JVM calling this method or not, or someone else is calling? What is the answer? Means maybe my question might be wrong at this scenario. Why? Because the JVM is the one which does everything internally, but when I say who is calling this method, the divide method is being called from the main method of throw and throws demo. It is being called from line number 8. So when I ask who is the caller of the divide method, okay, the divide method is being called by the main method in this class and from line number 8. First of all, is that clear to everyone? And this main method is ultimately being called by JVM. That I agree. But line number 8 is what is calling the divide method. Clear? So line number 13 will throw back an exception to line number 8. Okay, so it will throw back the exception to line number 8. So now at line number 8, is there someone who can handle this exception? Yes or no? Okay, very good. Now to whom will the exception be thrown? So who will get that exception after line number 8? After line number 8, the exception will be thrown. A simple scenario team again. After line number 8, the exception will be thrown to the caller of this current method. Who is the caller of this current main method? The JVM. So the JVM ultimately gets that exception and it will stop the program abruptly and it will not execute line number 10 in this current class. So if I complete the execution by pressing this F8, did you notice here it prints just 1111 for me because of line number 12, and it came back to this one and it never executed line number 9 and 10 for me because of an exception at that point. Okay, clear? Okay, so the concept here is, if suppose if the user has created his custom exceptions. See, in general, in real time, what we can do is we can create our own exception class. So I say class and say user custom exception. Okay, so one question to everyone: tell me how I can create a class, sorry, exception class in Java. Anyone? Using throw and no, not using throw and throws. See, I want to create a class which can handle exceptions. Like, see, did you notice here? The first thing that we saw here is IO exception. Extended from the pair. Very good answer, Krishna. See here, what we saw till now, we saw something like either an IO exception, which are like checked exceptions or unchecked exceptions. These are all the classes which Java has given for you. Now, can you write your own or can you define your own exception class? Yes, you can define your own exception class. So how can you do that? The simplest thing that I can say is create a class user, some any name you can say, user custom exception, and extends, I can say, runtime exception. Okay, it can extend from runtime exception. Now, in this runtime exception class, I will, in general, we will provide some basic methods like a constructor, public, user exception class, or user custom exception, or public, user custom exception, which can take in a string, MSG, string message. So, so now I say here, super of this one, I'll call this MSG. So see here, I have created a custom exception class now. So is it a checked exception class or unchecked exception class, team? Checked or unchecked? Very good. That is an unchecked exception. Why? Because it is extending from runtime exception. Now what I do here is I go to my some exception and I say, hey, throw new user custom exception class. User custom exception class. Like this I have written. And I'm passing a message. Now, if I go back and execute the program again, see, it handles the exception, and the exception it shows is, if you remember in the previous examples, all the exceptions when it comes or when it is printed, it shows java.lang.array index out of bounds, java.lang.arithmetic exception, which means it is trying to print the classes which are present in the packages. Okay. Now what I'm trying to say is com.easylearnjava.exception handling package, in that user custom exception class. In that the message is the denominator cannot be 0. This is what is being thrown for you. So you have created a custom exception class. Now at line number 9 or at line number 8, since I'm calling that method, I say that that exception is being thrown, and here there is no one to handle that exception, so it is not working fine. Okay, so now see here the next scenario. Here I say, okay, I come to some class and see the next use of a different keyword called throws. Throws, control V, user custom exception I wrote. Okay, a simple thing I wrote in the method declaration like throws. Okay, that is what I used. Now let me go back and rewrite this statement once again. The same statement I'm going to write again. Sc dot divide int a comma int b. That is what I am telling, and this is from some class. Okay. Now I say okay. When I say throws, it means that this is an informative message to the caller saying that, hey, your current class will throw these kind of exceptions. So you better handle them. That is what you are giving a heads up to the caller of this method. So in the previous scenario, are you telling the caller that what are the different kinds of exceptions that you are going to throw? Yes or no? Yes, very good. The answer is no. In the previous scenario, you never notified the caller saying that, hey, I throw all these kinds of exceptions. But here, in this current scenario, by using a throws keyword, you are just giving a heads up. You are just giving a heads up to the caller saying that, hey, caller, I'm trying to call or I'm trying to send uh, an exception of type user defined exception. That is what you are complaining. So that now what exactly the caller can do is the caller can handle user defined exception in this scenario, saying that try, okay, since when I call this one, the user might throw some exception of type user defined exception. So let me catch that user defined exception e, and I can say e dot print stack trace. Okay, so when I say e dot print stack trace, it means that it will print the message which is being sent for you, and it will also execute line number 99, this line number 15 also for you now. So now if I execute the same thing, did you notice it has executed one and it has printed line number 99, line number 15 also for you, and it is printing the message the denominator cannot be 0. Okay, now did you notice, did everyone notice the difference between throw and throws? Throw is for throwing a custom exception, and throws is for notifying the callers of this method that, hey, please be careful because I am going to send back all these kinds of exceptions to you, so that you need to handle them. That is what is the information. And one more real-time scenario I would like to say here. So let us assume that we are trying to save some data into the database. And when I'm trying to save some data into the database, like let us assume I'm trying to save some user registration details. In user registration details, I am trying to store the phone number, the email address. Okay. Now let us assume that the phone number is not in a proper format. Then what I can say is throw means I can create a custom exception class saying that invalid phone number exception, or if it is an email, I can create invalid email exception. Like that I can create different types of exception classes, and before I save I can compare, is the phone number in a valid format or not. If the phone number is not in a, here like this, like line number 7, I will check, is the phone number in valid format or not. If it is in valid format, then okay. If it is not in valid format, I will say throw new invalid phone number exception, and I will set some specific error message saying that, hey, the phone number is not valid. The next scenario, what I can do is I can check if the email ID is valid or not. Means I'm just giving an example of a equal to 0. It need not be, but I'm just giving an example. Here I can check is email ID. Here what did we check? Phone number in real time. Here what I can check is email invalid or not. If email is invalid, then I can say throw new an email invalid exception, and I can send some different custom message saying that improper email address is entered, or invalid email address, Like that you can specify custom message. If you want to check one more field like date of birth or age field, if age is greater than 100 you want to throw an error saying that, then you can write one more validation here. If age is greater than 100 you can say throw new age invalid exception, which means, did you notice here team, based on the type of error I am trying to create different objects. So here again I can say throw, I can say here like 3h throw new. If I have an email thing I can say throw new invalid email exception class. Like that I can do whatever stuff I want. Okay, so throw is basically used for throwing a specific type of exception, and throws is an informative message to the caller saying that, hey, these are the kind of exceptions which this method might throw. So if it throws, you please better handle them so that even if it throws, your code will execute fine. So throws is just an informative message and throw is for throwing an exception. Any questions or any doubts? Yeah, that's a good question. So what if we don't write throws? There is nothing wrong if you don't write throws. Okay, everything will be good. Okay, everything will be good. But if suppose if the user gets an exception, okay, he will not be aware of what kind of exceptions he needs to handle. Okay, so once the user gets an exception, then maybe he might go back and change his code, like whoever is calling this method, whoever is writing this code, they might go back and send. So throws is basically as an informative message. Okay, clear?
So yes. So in real case scenario now, do we use throws on like almost every single methods
Exactly,
for construction?
this is what we do. Like throws is what we do every time. We say it throws. What is the kind of, so in real time scenario you will have different classes with specific names. One is like a DAO class, service class. So for a DAO class method you will write throws DAO exception. For a service layer class you will write throws service exception. Like that you will specify that all these exceptions which are being thrown using a throws clause, throws keyword. Okay, maybe once we go into the advanced concept and do a single program end to end, like from the browser taking the data, sending it to the web layer, and from there trying to store it into the database, writing some business functionality and throwing back. In that example, which we will do in a week, not at least in a week, like in at least 4 or 5 days, then we will understand like how you are doing exception handling and how you are doing like sending back an exception by using a throws keyword and all this stuff. Okay. If you remove 16, now the catch handle it. If we remove 16, yeah, means, see here team, line number 16, whatever I have written, okay, has two things. Like let me just comment this out, remove this out, why? Because we are not throwing anything back. Oh, okay, so sorry, return. So the first thing is, when line number 8 is throwing something, it's not always mandatory to throw it back to the caller. If you want to throw it back to the caller, you can write a throw new in this in the exception block. But if you don't want to throw new, if you don't want to resend it back to the caller, you can just suppress the exception here itself. But that is not a proper way of coding. Whenever you get an exception, that needs to be thrown to the caller so that the caller will understand, hey, because of what I had sent, there is some exception, like that. So it's always better to do that, like throwing back the exception. Did that answer your question? Okay, yeah, that's good. Any more questions or any more doubts?
One more question.
Yeah, go ahead.
So after like all kind of exceptions, we write the exception E or whatever. Is that's going to be the last thing that we want to write on every case, or
Means
we don't really have to write exception? That one right there.
yeah. So assume one thing. Okay, assume one thing. So right now, line number 8 is throwing an exception, right? Now, do you want, my first question, do you want to do anything in the current method with this exception? Yes or no? Okay, first, let me answer both the scenarios, yes and no also. If I want to do something with this yes, then I will write the catch block. Okay, I will write this catch block and then I will write my own logic, like whatever I write, sysout 111 like this I will write. Okay, if not, what I can say is like, I will just write a finally block, leave it, and then give it, say that it throws. Or what I can do is simply I can write my catch block and I can just, I don't write anything in the catch block. I will straight away say that send it back to the caller. That's all I will say. Send it back to the caller who has called this. So in general, what we do is like, it's not always mandated to handle that. But if you want to handle, you can write it in a catch block and write whatever logic you want to write. If not, you can directly catch it and rethrow it back to the caller straight away. Okay.
Okay, so like if it's something, let's say, kind of like a area index,
Okay.
and so we mentioned catch area index,
Okay.
right?
Now I got your question. So as I said, real time, in real time, this is not a preferred exception, right? So what you write is in real time, throw, see, catch, user, customer exception E. Okay. So this is what only you catch. And if suppose when you're running your program, if this fails and this causes an email invalid exception, then you will write one more catch block saying that catch for invalid email and then you throw from there like that. You will, means ideally will not write catch exception E. Does that answer your question or still you have some doubts? Okay, yeah, that's good. So any more doubts or questions, team? Okay, I'm just stopping the recording. Okay, your question is like, when I say sc.divide, will it ever show that hey, the divide method is throwing back something for you? Will it show it or not? Okay, now first question for everyone, do or is it necessary to handle the runtime exceptions or not? Means okay, maybe let me rephrase the question. Is it mandatory to write a catch block for runtime exceptions?
Yes, it is mandatory.
Okay, so the answer is no. Why? Because the compiler will never ever complain if you don't write a catch block for runtime exceptions. Clear? Now, if I don't see, my next question is,
So,
yeah, do you have a question?
so runtime in the sense, what do you mean? The inputs that are given by the user?
Okay, runtime exception means line number 10 as a user, okay, I'm saying 31 and 0. I don't know about how the end class is implemented, how the divide is implemented, I don't know. So I want to divide 31 and 0 and want to see the output, right? So I go and say 31 by 0. But here it is throwing something called as a runtime exception class, right? So is it mandatory for this guy to write a try catch block? Is the compiler forcing him to write? Good. The compiler is not forcing him to write a try catch block. Why? Because the divide method is throwing an exception. But what is it? What is the exception of type? It is of type runtime exception. So that is the reason why we need not handle it. But let me tweak here a little bit. Whatever custom exception that I have created, let me make it as a compile time exception. Okay, let me make it as a compile time exception. Now answer my question. Is user custom exception, is it a checked exception or unchecked exception? It is a checked exception. Very good. Now do you need to handle the checked exceptions at compile time or not? Okay, so Krishna, I think you missed the concept. Checked exceptions must be
They have.
handled at compile time. Okay, so see here. Now when I say sc.divide, here it starts complaining the same class. Okay, the same class, it starts complaining in this current scenario. Why it starts complaining? If you hover your mouse, it says that hey, that exception needs to be handled. Why it needs to be handled in this current scenario? Why? Because I went and modified this exception explicitly as a checked exception, so which needs to be handled right now. So now if I handle that exception, the error is gone. So now did you understand, team? Like when I throw, so now see here, I am throwing user custom exception and arithmetic exception. Okay, there are two exceptions that are being thrown from the divide method. Now my question for everyone: when a caller calls this divide method, how many exceptions the user is expected to handle by the compiler? Since what are all the exceptions that the user must handle at compile time? Okay, Sai says one. Okay, Adip, it's not arithmetic exception. It is the user custom exception. Why? Because arithmetic exception is a runtime exception, which the compiler
Yes.
says, hey, even if you don't handle the arithmetic exception at compile time, I don't care. But this is of type checked exception. So you must handle this at compile time. If you don't handle the checked exception, I will start complaining. That is what the compiler says. So even though the divide method is throwing two exceptions, this class need not handle both in this current scenario. Why? Because only the compiler checks if we are handling checked exceptions or not. Is it clear to everyone? Okay, good. Now understand the next part of the question. Understand the next scenario, not the question, next scenario. In this scenario, there is one checked exception and there is one unchecked exception. So the compiler says, the compiler forces you to use a catch block for checked exception only. It will not force you to use this. But as a developer or as a programmer, it is better to write two catch blocks, one for this and one for this. Why? Because you will never know. If this exception comes, then your program will stop abruptly. Your current program will stop abruptly. Why? Because you are not handling an arithmetic exception. So it is a good programming standard or a practice to see what are all the types of exceptions that are being thrown. So handle all those exceptions. Concept clear?
Yes,
So
Raghu.
down
So
at the throw.
can you go?
Okay, one question at a time. Maybe Adit, can you go ahead?
So down at the throw, can you go to some class?
Okay.
So if arithmetic is not something that we'd have to worry about in the beginning, then the throw new user custom. Do we ever have to worry about setting up arithmetic or array index on throw or no?
Okay.
Or
So
is it always the user custom?
yeah, let us assume that when a equal to 0, okay, I'm writing a code like throw new arithmetic exception, numerator is 0, some message I'm sending. Okay, now what is that I'm trying to do? I am throwing this arithmetic exception back. Now see here, if suppose until I make this a 0, everything looks good. If I make 1 or 2 or 11 or 12 or anything, everything looks good and your program works fine, which means line number 15 will always be executed. If I make the numerator as 0, okay, and the denominator as something as 40 or 50 or something, now see here, your program is not working fine. Line number 15 is not working fine. Why? Because in this current context, arithmetic exception is being thrown. Okay, arithmetic exception is being thrown in this current scenario. So if suppose, means, are you handling arithmetic exception? No, you are not handling arithmetic exception. That is the reason why your program is not executing well. But if suppose, as a developer, if you see that, okay, two exceptions might be thrown from this divide method. So if you go back and handle that arithmetic exception also, catch arithmetic exception A and sys out A or A dot print status or whatever. If you do this in this current scenario, see, it prints whatever you want and it also completes your program execution like completes 999. So it's always a good coding standard or a practice to handle all the exceptions which are present in the throws block. But the compiler will never ever force you to handle arithmetic exception. The compiler only forces you to handle user custom exception. Why? Because that is of type checked exception. Is it clear, Adi?
Gotcha.
Okay.
Thanks.
Yeah. Next, someone, I think Sai or someone else has a question. Please go ahead.
Yes, Raghu. So if you go to like this throw and throws class,
Mhm.
yes, at line number 10 here, we're creating, I mean, we are calling a method divide, which is in some other class, right?
Mhm.
So when I'm just calling this divide, like sc.divide, when I'm trying to call this method, will that show that there are some exceptions being thrown by the method? I
Yeah.
mean, can I see from here itself?
Yeah. So to see it from here itself, there are two things. Checked and unchecked. The compiler will never ever worry about unchecked. So compiler will not show anything related to unchecked. Compiler only worries about checked. So if I remove this one, see, it started complaining, saying that, hey, there is something which you need to do. So if you go ahead and see here, then it shows that user custom exception, which is a kind of a custom checked exception which you need to handle. That is what it is showing. But it will never worry about the arithmetic or unchecked. That is the one thing which you can understand, like how it.
Yeah.
Okay.
So in this case, unless I run the program, I will not face any problem. So how to how to know that we should write like catch arithmetic exception block here. So
Catch arithmetic exception. So that's a good question. So in general, if you're trying to use a specific class, internally or ideally, you will get something called as an interface. Okay. So in general, if you buy any product or anything, if you want to use anything, you will get an interface for that class. So interface means it defines all the methods which are being used. So once you see the interface, in that interface, it will clearly mention like what are all the exceptions which are being thrown by a method. By looking at the interface definitions, you will understand, okay, these are all the methods which I can call, and these are all the exceptions which can be thrown by the methods. That is how you can understand basically by looking at the structure of the methods. Clear?
Yeah, okay. Yeah, okay.
Okay, so I'm sorry, I got one more. So earlier on, like, I'm not sure if it was a dummy class or temp class, but you know how we created, like, we wrote a bunch of codes for like arrays and the integer, this one right here. So when you have error on, like, say, the integer array, you got the error already, right? We know that. And then again down there by the integer a equals 5, we got the error there again. So when we're running this, it's gonna catch the array index first, and then without going through the next one, it's just gonna go down to the exception E, correct? Or down there by 222. Is there is there a way to like catch both of them at the same time, or is it's just one at a time?
It's one at a time. Why? Because when something goes wrong at line number 10, nothing can be executed after 10. Why? Because all these lines are skipped. It will never execute them. So it will not know what are the exceptions that might cause in the future.
Okay.
So
like
first
when you have
first we will fix this error. Like I will say, if d not equal to null, then only call this. Okay. So first I fixed this error, null pointer exception I fixed. Then I will fix this null pointer. Like that, you will step by step come and fix each and every issue.
Is that the kind of like unit testing, or you normally won't write code like that, right?
Means in general it can be considered as a unit testing, but when you're writing a code, means I will try to explain some scenarios. Based on that scenarios, as a user, you will understand that doing all these things are right. So you will add some precautionary steps like this. So you must
Okay.
never ever write an object. You must never ever use an object and say dot object dot. You must never do that without checking if the object is null or not. So this is a mandatory step that you must do on every object before you use it. So if you start using that coding standards, you will understand that, okay, you can eliminate at least 90% of exception handlings for null pointer. Like that, by following some certain coding standards, you eliminate these things. But definitely there will be some exceptions which you can catch it always and see at what line number they are being caused. You can always go back and fix them.
Okay.
Okay, clear?
Yep. Thank you.
So I hope it's clear to everyone. I'm just stopping the recording.